Suppose you have two wooden planks. One is 60 centimeters long and the other is 90 centimeters long, and you want to cut both into equal-sized tiles with nothing left over, using the biggest tile size possible. Now suppose instead two friends visit the same gym, one every 4 days and the other every 6 days, and you want to know after how many days they will both show up on the same day again. The first question is asking for the biggest shared piece size, and the second is asking for the smallest shared total. And we can answer both just by dividing and multiplying carefully. Let's go back to the planks, 60 centimeters and 90 centimeters, and try cutting both into equal pieces of some size, checking if there's nothing left over. Try a piece size of 10 centimeters. 60 divided by 10 is 6 pieces exactly, and 90 divided by 10 is 9 pieces exactly, so 10 works with nothing wasted. But can we go bigger so that we need fewer, larger tiles? Try 15 centimeters instead. 60 divided by 15 is 4 pieces exactly, and 90 divided by 15 is 6 pieces exactly. 15 also works perfectly, and it's bigger than 10. Let's push further and try 30 centimeters, the biggest guess yet. 60 divided by 30 is 2 pieces exactly, and 90 divided by 30 is 3 pieces exactly. 30 works too, with nothing left over on either plank. Try anything bigger than 30, like 45, and it stops fitting evenly into 60 at all, so we can't push further. So 30 centimeters is the biggest piece size that slices both planks evenly with nothing wasted. That biggest shared piece size is exactly what we call the highest common factor of 60 and 90. Now back to the gym friends. One visits every 4 days, the other every 6 days, both starting on day 0. List out every day the 4-day friend shows up, just by repeatedly adding 4. 4, 8, 12, 16, 20, 24, 28. Now list out every day the 6-day friend shows up, by repeatedly adding 6. 6, 12, 18, 24, 30. Look for the very first day that shows up on both lists. 12 appears on both, and it's the smallest number common to both lists. So 12 days is the smallest total gap, where both friends land together again. That smallest shared stack is exactly what we call the lowest common multiple of 4 and 6. Here's something neat. Let's go back to our plank numbers, 60 and 90, and check what happens when we multiply the highest common factor and the lowest common multiple of those two numbers together. Using the same listing method as before, the smallest number, both 60 and 90, divide into evenly turns out to be 180. Now multiply the biggest shared piece, 30, by the smallest shared stack, 180. That gives 5,400. And if you multiply the two original plank lengths together, 60 times 90, you also get 5,400. So the biggest shared piece multiplied by the smallest shared stack always lands exactly on the two original numbers multiplied together. A handy shortcut once you already know one of the two. So to find the biggest shared piece size, we kept trying piece sizes, checking division with nothing left over, until we found the largest one that worked for both quantities. And to find the smallest shared stack, we listed out repeated additions for each quantity and picked the very first number that appeared on both lists. Both ideas come from the exact same place, splitting quantities into equal-sized groups. Just one asks for the biggest group that fits evenly everywhere, and the other asks for the smallest total built from even stacks of each. A carpenter has 2 ropes, one measuring 18 meters and the other measuring 24 meters. She wants to cut both ropes into equal pieces, as long as possible, with no rope left over. How long should each piece be? Whenever we need the biggest piece size that fits evenly into 2 lengths with nothing left over, we look for the largest number of meters that divides both lengths exactly. We find that by repeatedly splitting the bigger length using the smaller one, shrinking down step by step until the leftover becomes 0. Take the 2 lengths, 24 and 18. 24 meters split into groups of 18 meters gives one full group of 18, with 6 meters left over. Now repeat with the smaller pair. 18 meters split into groups of 6 meters gives exactly 3 full groups, with nothing left over. Since we reached 0 left over, the last group size we used, 6 meters, is the biggest piece size that fits evenly into both ropes. So each piece should be cut 6 meters long. That gives 3 pieces from the 18-meter rope and 4 pieces from the 24-meter rope, with nothing wasted. One bus leaves a depot every 15 minutes, and another bus leaves the same depot every 20 minutes. If both buses leave together at 9 in the morning, after how many minutes will they leave together again? When we want the earliest time 2 repeating gaps line up again, we list out the stacked totals of each gap, 1 copy, 2 copies, 3 copies, and so on, until we hit a total that appears in both lists. Stack up copies of 15 minutes, 15, 30, 45, 60, 75, 90. Now stack up copies of 20 minutes, 20, 40, 60, 80. Looking at both lists, the smallest number that shows up in both is 60. So the 2 buses will next leave together 60 minutes later, meaning they meet again at 10 in the morning. A shopkeeper has 36 pencils and 60 erasers. He wants to pack them into identical gift bags so that each bag has the same number of pencils and the same number of erasers, using up every pencil and eraser and using as few bags as possible. How many bags does he need, and what goes in each bag? Using the fewest identical bags means each bag should be as big a group as possible, so we need the largest number that divides both the pencil count and the eraser count evenly. We find that by repeatedly splitting the larger count using the smaller one until nothing is left over. Start with 60 and 36. 60 split into groups of 36 gives one full group, with 24 left over. Now split 36 into groups of 24. That gives one full group, with 12 left over. Now split 24 into groups of 12. That gives exactly 2 full groups, with nothing left over. Since the leftover just became 0, 12 is the biggest group size that fits evenly into both the pencils and the erasers. So he needs bags that each hold 12 items in the same ratio. 36 pencils divided by 12 per bag gives 3 bags worth of pencils, and 60 erasers divided by 12 per bag gives 5 bags worth of erasers. Since every bag must be identical, he needs 3 bags, and each bag gets 12 pencils and 20 erasers. 3 friends are jogging around a circular track. The first one completes a lap every 8 minutes, the second every 12 minutes, and the third every 18 minutes. If they all start together at the same point, after how many minutes will all 3 meet again at the starting point? When 3 repeating gaps all need to line up together, we build up the stacked totals of each gap and look for the smallest total that shows up in all 3 lists. With 3 numbers, it helps to first find the smallest common stack for 2 of them, and then combine that answer with the third. First, combine 8 and 12. Stacking 8 gives 8, 16, 24, 32. Stacking 12 gives 12, 24, 36. The smallest number common to both those lists is 24, so every 24 minutes the first 2 friends are together. Now bring in the third friend's gap of 18 minutes. Stack up copies of 24, 24, 48, 72, 96. Stack up copies of 18, 18, 36, 54, 72. The smallest number common to both these new lists is 72, so all 3 friends will meet again at the starting point after 72 minutes. 2 containers hold 84 liters and 126 liters of juice, respectively. A vendor wants to pour the juice into identical smaller bottles, each holding as much juice as possible, with no juice left over in either container. How many liters should each bottle hold? The biggest bottle size that empties both containers exactly with nothing left over is the largest number of liters that divides both quantities evenly. We find that by repeatedly splitting the bigger quantity using the smaller one until the leftover hits 0. Start with 126 and 84. 126 split into groups of 84 gives one full group, with 42 left over. Now split 84 into groups of 42. That gives exactly 2 full groups, with nothing left over. The leftover just became 0, so 42 liters is the biggest bottle size that fits evenly into both containers. So each bottle should hold 42 liters. That gives exactly 2 bottles from the 84-liter container and 3 bottles from the 126-liter container. Find the smallest number of oranges a vendor could have, if the oranges can be arranged into rows of exactly 6 or rows of exactly 8, with none left over either way. We need a total that can be built as an exact stack of 6s and also as an exact stack of 8s, and we want the smallest such total. So we list out the stacked totals of 6 and of 8 until one number appears in both lists. Stack up copies of 6, 12, 18, 24, 30. Stack up copies of 8, 16, 24, 32. The smallest number appearing in both lists is 24. So the smallest possible number of oranges is 24, giving 4 rows of 6 or 3 rows of 8. A tailor has 2 rolls of cloth, one 45 meters long and the other 105 meters long. She wants to cut both rolls into pieces of the same length, as long as possible, with nothing left over. How long should each piece be, and how many pieces will she get in total? To get the longest possible equal piece, with nothing wasted from either roll, we need the largest number of meters that divides both lengths evenly. That comes from repeatedly splitting the longer length using the shorter one until the leftover reaches 0. Start with 105 and 45. 105 split into groups of 45 gives 2 full groups, with 15 left over. Now split 45 into groups of 15. That gives exactly 3 full groups, with nothing left over. The leftover just hit 0, so 15 meters is the longest piece size that divides both rolls evenly. So each piece should be 15 meters long. The 45-meter roll gives 3 pieces, and the 105-meter roll gives 7 pieces, for a total of 10 pieces. 2 numbers have a biggest common piece size, that is a highest common factor of 9, and their smallest common stack, that is their lowest common multiple, is 189. If one of the numbers is 27, what is the other number? There is a neat link between the 2 numbers themselves and their biggest common piece size together with their smallest common stack. Multiplying the 2 original numbers always gives the same total as multiplying their biggest common piece size by their smallest common stack. So we can use that link to recover the missing number using only multiplication and division. Multiply the biggest common piece size by the smallest common stack, 9 times 189. This total, 1,701, must equal the 2 original numbers multiplied together. We already know one of them is 27, so divide 1,701 by 27 to get the other number. So the other number is 63. We can double check. 63 and 27 do share 9 as their biggest common piece size, and stacking them evenly does first meet at 189. In a hostel, one water tanker refills a tank every 24 days, and another refills a different tank every 36 days. Both tankers came on the same day this month. What is the smallest number of days after which both tankers will come on the same day again, and how many times will the first tanker have come by then? To find when 2 repeating schedules next line up, we stack up copies of each gap and look for the smallest total common to both lists. Stack up copies of 24 days, 24, 48, 72, 96, 120. Stack up copies of 36 days, 36, 72, 108, 144. The smallest number in both lists is 72, So both tankers will next arrive on the same day after 72 days. To find how many times the first tanker came by then, divide 72 by its own gap of 24 days, which gives 3. So the first tanker will have come 3 times by that day, counting the very first visit. A warehouse has 210 red boxes, 252 blue boxes, and 294 green boxes. All boxes must be arranged into identical stacks with only one color per stack, every stack in the warehouse having the same number of boxes and no box left unstacked. What is the largest possible number of boxes in each stack? We need the largest stack size that divides all 3 box counts evenly. With 3 numbers, it helps to first find the biggest common piece size for 2 of them, and then combine that result with the third number the same way. First, combine 210 and 252. 252 split into groups of 210 gives 1 full group, with 42 left over. Now split 210 into groups of 42. That gives exactly 5 full groups, with nothing left over. So the biggest common piece size of these 2 is 42. Now bring in the third count, 294. Split 294 into groups of 42. That gives exactly 7 full groups, with nothing left over. Since 42 divides all 3 box counts exactly, 42 is the largest possible number of boxes in each stack.